So welcome back to Frequency Online Maths. We are still on sequence and series. So today we are going to talk about geometric progression or what sequence. Now, what is this geometric progression? It's very simple. So if in a sequence, if you want to get the succeeding term, if you multiply the preceding term by a fixed number, a constant value, and you use that constant value after multiplying it, you get your succeeding term, and you use it throughout the sequence to be getting your succeeding term. That sequence is known as what? A geometric what? Progression. And that constant value that you are using to multiply each preceding term is known as what? Common ratio. And let's read what is on the board. They say if in a sequence of term, each succeeding term is generated by multiplying each preceding term with a constant value, then the sequence is called a geometric progression, GP, whereas the constant value is called the common ratio. Now, for example, if you have 2, 4, 6, what am I writing? 2, 4, 8, 16, 32, 64, and so on and so forth. Now, you have this is a sequence. Let me write it here. Sequence. Now, 2 multiply 2 will give you what? 4. Are you seeing that I'm having a constant value? I'm multiplying it with a constant value. 2 multiply 2 will give me what? 4. 4 times that same 2 will give me 8. 8 times that same 2 will give me 16. 16 times that same 2 will give me 32. 32 times that same 2 will give me 64. Are you seeing that I'm using a constant value, which is called what? The common ratio, which is what? 2. Are you seeing it? So our formula, that's Tn is equals to ARN minus what? 1, where A is the first term, where A is first term, R is common ratio, common what? Ratio. You can still say that that geometric progression is the ratio between the succeeding term and the preceding term. If the ratio is constant, it is term as what? Geometric progression. Let's say ratio between this thing. You know that ratio is division. 4 divided by 2 will give me 2. 8 divided by 4 will give me 2. 16 divided by 8 will give me 2. So any definition you want to use, you can use. You get? Now, R is the common difference. This is the nth term of what? A geometric what? Progression. Now, and another thing you need to know about this geometric progression, let's just test this nth term formula. For example, we want to find the fourth term. Let's assume that we don't know this fourth term. It will now be T4 is equals to, first term is what? 2. 2. Our common ratio is what? 2. As you can see, we are using 2 to multiply this thing. Common ratio is what? 2. So that is the R. So we have 2. Then N is what? Because we are finding number of term, which is 4. I forgot to write it here. N is 4. So 4 minus 1. So T4 will now be 2 times 2, which is what? 4. 4 minus 1, which is 3. 4 to the power of 3 will give me what? T4. 4 to the power of 3 will give me 4 times 4 times 4. 4 times 4 is what? 8. 8 times 4 is what? 32. So I'm going to have okay, sorry, I made mistake. What did I even multiply? I did not make use of normal indices, sorry. So this thing is 2, right? Now times 2 to the power of 4 minus this will give me 3, right? So I'm going to have, you know that this thing is 2 to the power of 1. So since the base are the same, we are going to have 2 to the power of 1 plus 3, which is 2 to the power of what? 4. So can you even see it? So 2 to the power of 4 is equals to what? 16, because 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So the first term, 1, 2, 3, 4, is what? 16. So that's it. Now, what we need to know again in this geometric progression is called the, that I've told you what series mean now. For example, series of this all this term is simply what? 2 plus 4 plus 8 plus 16 plus 32 plus 64. That is series of what? This GP. That is series. Just add everything, all the elements in this sequence. That is series. Now, the sum of series, the formula for sum of series of a finite series. Let me write it. Finite. They are just speaking English. Finite is something that is defined, something that has beginning and has what? End. For example, exercise book is finite because they may say 80 leaves. If you reach at 80, it must stop unless they want to do Jarafon. So sum of finite term is denoted as that's sum of series of finite sequence is denoted sum of series of a finite sequence is denoted as a times 1 minus r to the power of n all over 1 minus r. That's the sum of what? Series of a finite word sequence. Now, sum of series, and there is criteria for this. If r is greater than 1, that's the absolute value of r. Absolute value simply means, for example, absolute value of 4 is still the same thing. 4 simply means how far a number is away from what? 0. So absolute value of minus 4 is still the same thing as what? 4. So if it is positive, just keep the positive like that. If it is negative, the answer will still be what? Positive. So that's absolute value. Now, for infinite, infinite. I told you in Latin it's called ad infinitum. It does not have end, forever and ever. So now it is noted as S infinity like this is equals to, it's the same formula but you're going to cancel this one, so it will now be A all over 1 minus R. So that's the formula. If R is less than 1, that's absolute value of R is less than 1, the series converges. This one, if it is greater than R, it diverges. Diverge means it does not have end. It will be going like this, divergent. You don't know where it will end. But converge means it will come to one place. So, for example, this series, let's check whether it is that it will diverge or converge. This series, let's check. So we have the common ratio here, which we have found is what? 2. So is 2 less than 1? No. You understand? So 2 2 is not less than 1. I hope you can see it from there. So this 2 is greater than 1. Therefore, this series diverges. This sequence or this series does what? Diverges. So it diverges because it is what? This 2 is greater than 1. Are you seeing it here? The R, which is the common ratio, which we found here, is greater than what? 1. It diverges. But if it is less than 1, it will do what? Converge. So this thing will continue till what? Infinity. We don't know. We keep on adding, keep on adding. We don't know where we will stop. You get? So that is it. I don't think there is any other thing you need to know about this. Okay. Geometric mean. When we start treating arithmetic mean, we are still going to do video separately on that geometric mean. You understand? So that is it. Thank you for watching and may God bless you. Bye bye.